in making x1 units of product 1, x2 units of product 2, and x3 units of product 3. This is 5 hours per unit multiplied by x1 unit. So unit and unit cancel out, right? So give you 5x1 hour use up plus 2x2 hours plus 4x3 hours. All this represents the total usage of labor hours. Cannot exceed 240 hours. So you can see here, this part here. Are you okay? Left hand side is the total consumption of the labor resource in hours. Right hand side is the availability of the resource. Capacity. Left hand side usage cannot exceed right hand side. At most equal to. So when you get to see, there's a choice between using a less than or equal to or equal to. Always go for the non-negative, the non-equality, less than or equal to in this case. Right, in the case of the 2 months company, right, 6x plus 1y greater than or equal to 12. Right, because minimum we must produce 12 times or hybrid or we can produce more. So left hand side was meant to be equal to or greater than the right hand side. Here is the left hand side usage cannot exceed what is available. The maximum capacity is only 240 hours on a per day basis. Yeah? You cannot exceed that. So far so good. Then if I put like this, you know that this represents the total consumption of the material resource already, right? 4x1 plus 6x2 plus 3x3. Now 4, 6, and 3 is what we call coefficients. Coefficients of x1, x2, x3 in the left hand side of the non-equality. Cannot exceed 400 pounds. So in making x1 units of product 1, I need 4 times x1 pound plus 6 times x2 pound plus 3 times x3 pound. Cannot be more than 400 pounds, as you see here. So it's a class, okay, linear. All these are linear functions. And if I put next to the profit contribution, then I'm looking at total profit like this. Every unit of product 1 gives you a $3 profit, right? Therefore, x1 units will give you how much? 3 times x1 dollar plus 5 times x2 dollar plus 2 times x3 dollar, which you want to maximize. You put it as an objective function Z. Z represents total profit contribution given by this sum of these 3 terms. Alright, and you want to make it the largest value. So what should x1, 2, and 3 be? Alright, and that comes from the solution to this linear program. In this case, it cannot be solved by graph because we have x1, x2, x3, 3 variables. Alright, we can only solve by using simplex solution technique or using computer solution program. Okay. Anyway, you got an idea already. So you can see here, formulation. You can see here. Once we define this, we can link already, right? Objective function. We can also link to the so-called constraints. Because our x1, x2, and x3 are defined as per number of units of product 1, 2, and 3. Alright, so that's how we link. And then non-negativity constraints. Whatever we produce of product 1, 2, and 3, we can choose not to produce it, yes. But we cannot end up with negative quantities of the product. Non-negativity constraints. x1, x2, x3 greater than or equal to 0. Now later on in the graph, if you are looking at 2 variables only, x1, x2 greater than or equal to 0, it must be on the first quadrant of the graph paper, right? X is positive or 0. Y is positive or 0. So it's the first quadrant of the graph paper. Right? Cannot be negative side of x, negative side of y. Are you okay? Right, so when you have a choice between using an equality or equality, always go for the non-equality. Right? Because if you were to actually set equality, then that might be a case of over-constraining the problem. Okay? So that is what we will not want. So collectively, you put it together, you can see this order. Alright, objective functions on top. Maximize or minimize. Subject to constraints. In this case, there are 2. One is labor, one is material, right? And then the final one is the implied constraint, non-negativity constraint. x1, x2, x3 greater than or equal to 0. Meaning, in my final optimal solution, I can choose to have, let's say for example, in this case, maybe X3 I don't want to produce because why? Contribute the least profit one. Alright, so I may choose not to produce X3, possible. But I cannot end up with X3 taking on a negative value, minus 5 units. It doesn't make sense. Okay, minimum is 0. So it's a class, okay. Alright, so this is the so-called steps. So once you understand this, try this. Alright, you can see here, this one here, no more calculated data, is one chunk of information thrown at you. And then you have to actually read through, understand, and then analyze. Okay? But in the first question, I'll give you some help in the next page. Now notice this question was a 1992 zonal exam paper. There are 3 parts, A, B, and C. This is the first format I told you, where you are actually asked to formulate, you are asked to solve, and then answer or discuss theory, right? Discuss assumptions and so on, with respect to this problem. We are not doing B and C here. We are only doing A. Okay? So it's a carpenter's problem. I'll give you 5 minutes to formulate the linear program. And the helping words are on the next page. Basically, this is define decision variables T and C. Okay? And I also break down for you already. We are going to maximize profit subject to 3 constraints: carpenter's working time, customer's demand, storage space, and non-negativity constraints. Work on it. After, we'll compare notes.